So lesson 4.6, we are just identifying the three main laws or rules of logarithms. So starting off with this guy right here, anytime you want to add two logs together, we combine them with multiplication. So I can rewrite these with a common log, but I would multiply x times y. So I would get this look here. Anytime I am subtracting, I use division to combine them. And then anytime I have a number in front of the log or something being multiplied times the log, that can become the exponent. These follow your basic rules of exponents. Remember that anytime you're multiplying two bases together when you're dealing with exponents, the rule is to add their exponents together. Anytime you were dividing two items, the rule was to subtract the exponents. And anytime you have a power raised to a power, the rule is to multiply. And so that's where those rules come from. So here's a couple basic examples that you're going to run into. So if I have multiple logs taking place here, I can combine them into a single log by just using those properties that we saw up above. There's a lot going on here, so here's kind of the way I've always wrapped my head around it to get to the answer pretty quickly. Simply put, if any log is led by a positive, it will go on top. So I know this concept is going on top, and this one is going on top. Anything that's led by a negative would go on bottom. Again, this kind of follows the property of exponents, where you have a negative exponent, those things go on bottom. So here we go. So for this one here, I know that this b and this c to the second power is going to go on top because they are both positive. And I know this a to the 1/3 power is going to go on bottom because it's led by a negative. So that's just a quick way of putting that all organized into order just by recognizing their signs. And so I can go from this look to this look pretty quickly by just using that basic idea. Solving for k, this is super popular for IB type questions and test style questions. So example 2 here is definitely one you want to be familiar with. So if we have this look here, they're saying this is going to equal the natural log of something, so figure out what that something is. If I follow the same basic properties that I just did in the last one, remember that positives go on top and negatives go on bottom. So right off the bat, I can say, well, 2 to the 3rd power is going to go on top. So is 6 to the 2nd power. That's going to go on top. And I have my 4 on bottom because he's led by a negative. So I can quickly get to the end by looking at that. So I would say, well, let's do 2 to the 3rd power times 6 to the 2nd power. All that's going on top. And then I'm going to divide that by 4. And that gives me this look that you see here. So I'm looking at the natural log of 72. So if I compare that to the natural log of something, that means my k is sitting in place of the 72. So that's where we get our solution for k. These last ones this one's just going the other direction. So for example C here, I now will have a single log and I'm looking to expand that into multiple logs. This is another IB style of question that you really want to be familiar with. After I expand the logs, I got to take what's set up here into account. So this one's telling me that log base 2 of a can be substituted with an x, and log base 2 of b can be substituted with a y. So I'll come back to that in just a second. But if I take this and expand it, then I can say, remember that multiplication is separated by a plus sign. I know that the power rule says that I can take an exponent and bring it to the front of the log through multiplication. So we're going to separate those two guys with a plus sign. I can take the exponent and bring it to the front of the log through multiplication. Now I can substitute what it said up in the beginning, where it said log base 2 of a can be substituted with an x. So I'm replacing this guy with the x. I can replace this one with my y, so 2 times y, and I can get that look here. This is another common question that you definitely want to be familiar with. One more example of that right here. Remember, anything on top gets a plus sign, anything on bottom gets the minus sign. So in this case, we're separating those two guys out with a minus sign. Gives me this look here. You don't really want to deal with radicals when it comes to expanding logs, so we're going to write that with a 1/2 exponent instead of a square root. So I'm going to get this look that I see right here. I can take the exponent, put it in front of the log. So that's what you're seeing in this case, and now I can sub in my x and y for what they gave me up above in order to get this look here. So here's another case, another really common IB style question, so you're going to be glad you're watching this video. These are style of questions that you definitely want to be familiar with here. So in this case, we have this to start with, so the natural log of all this stuff going on right here. But then they want us to identify things in terms of P, Q, and R, and over here they tell you what P, Q, and R represent. So we just have to do a little substitution at the end to identify what those values would look like. So again, going back to our main basic rules of logs, remember anything on top gets the plus sign, anything on bottom gets a minus sign. So I know I'm going to have the y with the plus sign. Remember, we're going to see this as x to the 1/3 power. And then obviously this guy is going to get a minus sign in front because he is on bottom. So just following the same basic rules that we did up above, you're going to get this look here. So I got the y. Remember, that's led by a positive because it was on top. So is the 1/3 natural log of x that I get right here. And then the z that was on bottom gets the minus sign, and we brought his exponent in front, just following those basic rules that we did up above. But now I need to sub in the values for p, q, and r. So it said up above that p represented the natural log of x, so I'm replacing the natural log of x with a p value. All right, same thing that I did with substituting q in for the natural log of y, and then r for the natural log of z. And so you get this look right here. Again, this is another common test style of question, so it's good that you're seeing the video for this. For this last part, you got two options for putting certain things into a calculator with logs, and I kind of hinted at this in the last video, but if you need to come in, I got some pretty good tricks and things that you can do with a lot of the newer style calculators that will help you out. In general, if you have log base of b of a, remember calculators will automatically do a base of 10, and so the only way to, if you have some other base that's not a 10, well, how do you put that into your calculator? This is one way. This is called the change of base formula, where I can do the log of this divided by the log of this into my calculator, and that's just one way that a calculator can get you an answer for this when it's not a base of 10. The newer calculators, if you go under the button that says Math, scroll down to the one that says Log Base, and that will allow you to sub in any base that you want. So on the newer calculators only. So some of the older calculators, you have to take this route, but on some of the newer ones, you can sub in any base you want. And so just go to Math, go down to Log Base, and you can type it in exactly the way that you see it here, and still get the same answer. So give that a try on your calculator. Make sure you know how to do that if you got some of the newer ones. Same with this one here. So I could either do the log of 525 divided by the log of 8. That's one way of putting it into a calculator. If you got one of the newer ones, or if you ever are using one of my calculators during a test, which I have a class set, so you can use mine during the test. If you go under Math, go down to where it says Log Base, and you can type it in just the way that you see it here, and also get these answers. One last reminder on 3 sig figs. So remember, this is the common way of responding, is with 3 sig figs, unless directions say otherwise.